What we're going to do today is we're going to practice more with log equations. We're also going to bring in a little bit of exponential equations as well. But I want to start off with the do now. Now I'm going to try to write these bigger. Some of the complaints about the videos is it's hard to see, so I'm going to try to fix that today. With a little luck, maybe you guys will be able to see better. Give these two a try. So take a look at these, write them down in your notebooks, and pause me and see what you come up with, and then I will try them. All right, hoping you pause me, and now I'm going to do them, and let's see how you did. So when I look at this, I'm going to rewrite it as the natural log of 1 over e to the 1/2 power. So that's 1 over e to the 1/2 power. Now I'm going to look at this and say to myself, okay, it's a division question, so I'm going to expand it. When I expand it, both of these, the 1 and the e to the 1/2 will get their own natural log. So I get natural log of 1 minus the natural log of e to the 1/2 power. Now, natural log of 1. Anytime you ever get a log, any kind of log with a 1 next to it, that's a 0. Minus, now using log rules, right, in the land of the logs, exponents fall in front, so this becomes 1/2 natural log of e. Now, I'm hoping you remember that the natural log of e is always the number 1. So this becomes 0 minus 1/2. So the answer to the first do now is 1/2. So I'm hoping you got that. All right, next do now. This is a log equation. It's kind of the opposite of the one we just did, and the one we just did, it was condensed. So we gave it more logs. In this situation, it's got a minus sign in it. So to solve it, we have to condense it, meaning get it down to 1 log. So minus means division. So this becomes the natural log of 2x plus 3 over x plus 4 equals 3. Now I'm going to rewrite it. Now we have to rewrite it using Ben. And remember that anytime you have a natural log, the base is actually e. So now this becomes e to the 3rd equals 2x plus 3 over x plus 4. Now, this one side is a fraction. So make e to the 3rd look like a fraction, and I'm going to cross multiply. So that gives me e to the 3rd x plus 4 e to the 3rd equals 2x plus 3. Now we're trying to solve for x. So that means we're going to get everything with x's on it on one side, everything without x's on it. So I'm going to subtract 2x, be over here, and I'm going to subtract 4e to the 3rd to go to the other side. Well, that makes e to the 3rd x minus 2x equals 3 minus 4e to the 3rd. Right? Now, the reason why we did that is we can factor out an x here. Oops, that'd be a 2. So I factored out an x, and I have e to the 3rd minus 2 equals 3 minus 4e to the 3rd. And now all I have to do is divide by e to the 3rd minus 2. So that's one of the answers. Or you could have the opposite. You could have had negative 3 plus 4e to the 3rd all over 2 minus e to the 3rd. Either one of these is correct. Any version of it. Okay. So those are the do nows. Okay, so now what we're going to do today is we're going to do solving trickier log equations. And these are the problems we're going to work on. What we're going to be doing is solving exactly. So you can say, don't need a calculator for these because we can leave them in fraction form. But let's take a look at this first one. We have 5 to the x equals 2. Now, we have done other questions in the past where we have things like 9 to the x equals 27 to the x plus 1. And in situations like this, we want to make them common bases. So we would have changed this into 3 squared to the x. And this one here would have been 3 to the third, right? So this would have been 3 to the 2x equals 3 to the 3x plus 1. And once you have a common base, then all we have to do is solve for the exponents. So subtract 3x over, I get negative x equals negative 1, so x equals 1. All right, so this is an exponential equation. And the reason why it's an exponential equation is we can make them into common bases. Okay? Problem here, we cannot make these common bases. So there's going to be another way to do it. And that way is using logs. What I'm going to do is write log in front of both sides of the equal sign. Now I'm doing that for 2 reasons. One, I want now just made them a common base. They're both common base log base 10. And I have to do it to both sides to keep my equation balanced. All right, so now, reason why this works is because using our properties of exponents, where does this exponent want to fall? In front. So this becomes x log 5 equals log 2. And now I just have to divide both sides by log 5. And this is the answer to the question. And that's considered an exact answer because I'm not giving you a decimal. Now there is another way of writing this. All right. Another way of putting this all together so you don't have to write it like that is sometimes we take, I'm going to draw an arrow over here. Sometimes you can write this log x equals log base 5 2. This answer and this answer are equivalent. This answer and this answer are equivalent, so you can actually take both. The reason why I can get that is because come back up here. This, right, if you wrote this using Ben, right, you can get, but unfortunately what ends up happening is sometimes you don't see this as an option, they only have that as an option, so when you're thinking about multiple choice, you have to understand that both of these mean the same thing as that guy. And I'm going to do that a couple of times today. All right. So let's take a look at this next one. I'm going to solve for it. I'm going to draw a line here actually to separate these. Okay. This next one is 3, 1.45 to the x equals 20. Now it's very similar to the last one. We're just going to have the first step where I divide everything by 3 first to get the base alone. So this will be 20 over 3. Okay. Now at this point you could bend this. So, one solution could be x equals log 1.45 20 over 3. That's an acceptable answer sometimes. And again, next year on the AP and things, that could be multiple choice. Or we can log both sides. So you get log 1.45 to the x equals log 20 over 3, right? X falls down in front using our properties. So I have x log 1.5 equals log 20 over 3. And now to get x alone, I would get, oops, I didn't do that. It would be log, oh, I have my white outie thingy. I'll use that so you guys can see better. So we have log 20 over 3 all over log 1.45. So these two answers are equivalent. Those two answers are equivalent. And they're exact. Okay. And this one now. Let's take a look at this. Draw another line. Okay. Now, this one's already a log equation. So that means we're going to rewrite it. And what is the base if you don't see a base there? Correct? It's a 10. This would be 10 cubed equals 3 times 2 to the x. And 3 cubed is 1,000. All right, now I want to solve for x, so I want to get 2 to the x alone, so I'm going to divide both sides by 3. I'm going to do 1,000 over 3 equals 2 to the x. And now I can log this sucker. So I'm going to do log 1,000 over 3 equals log 2 to the x. Again, exponent log rules, the exponent falls in front. And then divide by that guy. So this would be x equals log 1,000 over 3 all over log 2. And that's the answer to the third one. All right, so we're going to do some more of these. Expose you to a few different things here. Now we're going to solve exactly, when we slide this down, for these guys. So this is e to the x plus 5 equals 7 times 2 to the x. So now they're getting trickier. But if you notice, when it comes down to things, the fact that the bases are different, that's the problem. And the best way to fix it is to log it. Now, we've got e in this problem. So we're going to bring in natural log instead of regular log. So I'm going to do natural log e to the x plus 5 equals the natural log of all of this. Now, log rules. This is going to fall in front. Now, both of these are coming down in front. So I'm going to put it in parentheses. Right, so I got x plus 5 in parentheses, natural log of e equals the natural log of 7 times 2 to the x. But, log of e, right? What is that? That's just 1. So this side becomes x plus 5. Now, check this out. Natural log, you're multiplying. While using our log rules, multiplication can turn into addition. All right, and finally, this x can fall in front. So x plus 5 equals the natural log of 7 plus x natural log of 2. Now, let's keep in mind, what are we trying to do here? We're trying to solve for x. So just like in the second do now question, we want to get everything with x's on one side, everything without x's on the other. So I'm going to bring this up here, and I'm going to subtract him over. So I end up with x minus x natural log of 2 equals natural log of 7 minus 5. Right? So I'm getting everything with x's. Now factor out your x. Natural log of 7 minus 5. And to get x alone now, divide. That's natural log of 7 minus 5 all over 1 minus natural log of 2. And that's the answer to the question. It is not pretty, but it is okay. All right. Now, let's look at this guy, number 5. What do you guys think we should do? Most of you know me a long time. If I see a fraction, I'm going to set the other one, make it look like a fraction, and cross multiply. So this guy times this guy is 3 to the x equals 5 to the x minus 1 times 2 to the x minus 1. Now, here's one of the rules for exponents everybody used to forget. These guys have the same exponent. They have the same exponent. What are you allowed to do with the bases? Oh, that's right. Multiply them. So that becomes 10 to the x minus 1. And now we're going to log it. So I'm going to log this guy. Now, I'm going to start cutting back on the steps. When you log this, what is going to happen to these exponents? That's correct, right? They're going to fall in front. So this becomes x log 3. Now, since there's two exponents here, you want to put it in parentheses. Log 10. Like that. But magically, what is log 10? Remember, there's a little 10 there. This guy I just underlined is the number 1. So if I bring this back up here, we have x log 3 equals just x minus 1. Now, just like the last question, right, we're solving for x. So we want everything with x's in it on one side of the equal sign. So we subtract the x over. Now I can factor out the x. And then get x alone. So it's negative 1 over log 3 minus 1. Look at that. Interesting answers. Okay, now let's look at this next sucker. He's interesting. Look at that. All right, so what is your gut feeling that you want to do? And I'm hoping you're saying, hey, let's get the 2 and the 3 together, and maybe e's together. So what if I subtract him over to this guy and subtract him over? So if I subtract the 2 over, it comes negative 5. And if I subtract this guy over, it's e to the x minus 2 minus e to the x minus 1. So I got everything with numbers, the plain constants on one side, the exponential functions on the other. Now, I don't know what that sound was, but now let's talk about exponent rules. Right, real quick. If I gave you e to the x times e to the negative 2, if you're multiplying, what are you allowed to do to the exponents? You're allowed to add them, which makes e to the x minus 2. Well, look what I have here. E to the x minus 2. That means we can go backwards. I know you're not going to like this, but check it out. It's pretty cool. Bring down the negative 5. This e can be broken up to be e to the x times e to the negative 2 minus this guy can be broken up to be e to the x times e to the negative 1. What do both of these have in them now? That's right, e to the x, which means I can factor it out. So I factor out e to the x on the right-hand side, and that leaves me with e to the negative 2, right? And e to the negative 1. All right. Now, trying to solve for e to the x, I'm going to divide. Equals e to the x. All right. Now, in this stage, I can log both sides. Right, so this becomes, I'm going to bring it back up here, the natural log of negative 5 e to the negative 2 minus e to the negative 1 right, equals x natural log of e. But guys, what's this guy, natural log of e? That's right, it's a 1. And that means this question is done. So x equals natural log of negative 5 all over e to the negative 2 minus e to the negative 1. I know that was nuts, but interesting, I thought. All right. Almost done. Almost done. 3 more. And these 3 are awesome, because this is what we call exponential functions in quadratic form. So I'm going to write that over here. Exponential functions in quadratic form. Right? This is really a quadratic equation. And you're like, Miss Duffy, how in the world is it a quadratic equation? Well, I want you to notice something right here. See how there's an e to the x there? See right there how there's an e to the x? Watch what I'm going to do. I'm going to let y equal e to the x. So now every time I see a y here, I'm going to substitute e to the x here, I'm going to substitute in a y. So right here I'd be y with a squared on it. So this guy becomes y squared minus 2 times y minus 15 equals 0. Holy cow! It's a quadratic equation, which now can be factored. This factors into y minus 5, y plus 3 equals 0, which gives me two answers, y equals 5 and y equals negative 3. But this question didn't have y's in it to begin with. So now at the very end, we bring back in our e to the x. So right here, this becomes e to the x equals 5, e to the x equals negative 3. Now, no exponential function can ever equal a negative. Can't happen. So this guy gets rejected. And it's only this guy we have to finish. We have to get x, solve for x. So we're going to log it. X, natural log of e, equals the natural log of 5. But what's the natural log of e? 1. So this guy just becomes x equals natural log of 5. And that's the answer to the question because he's the number 1. All right, we're going to do the same idea for this one. What would I let y equal to in this one? Correct, 3 to the x, right? Because right here, we have a 3 to the x. And right here, I have a 3 to the x. So I'm going to let y equal 3 to the x. And when we do that, I get y squared minus 5y minus 36 equals 0. So I'm going to factor this guy. Y minus 9, y plus 4. So we get two possible answers here. Y equals 9, y equals negative 4. Now again, this question did not have a y in it to begin with. So I bring back in my 3 to the x. 3 to the x equals 9. 3 to the x equals negative 4. But this can't happen. Right? This answer can never be negative or 0. So if you see 0 or a negative, we know we can cross it off. And check this out. 3 to the what power makes 9? That answer is 2. Look at that. We actually got a normal answer for one of these. And finally, I just want to show you this one. It's pretty awesome. Look at this one. Log base 3, 3x minus 4. Log base 2, 4x has to equal 0. What the heck are those answers? Well, to do this is actually a lot easier than it seems. I'm going to bring you back up to this step. Isn't this two different things being multiplied together equaling 0? And how did I get these answers here? By setting each of these pieces equal to 0. So no matter what kind of equation you have, guys, whether it be silly quadratic or crazy looking log, if you have two different things being multiplied together equaling 0, the only way it can equal 0 is if each individual piece equals 0. So you set this guy equal to 0, and then the other guy equal to 0. And then we're going to solve these using Ben, base exponent number. So it's 3 to the 0 equals 3x minus 4, right? So that's 1 equals 3x minus 4. Add the 4 over. Divide by 3. I get 5/3. Okay, now this one is 2 to the 0 equals 4x. 1 equals 4x. Right? Divide by 4. And I get 1/4. Now, I'm not circling them yet because this is logs. We got to make sure that these locations are not going to be 0 or negative. And if I plug 5/3 in there, we get 1, so that's okay. If I plug, I get 1 as well. So these are the two answers to the question. All right, so this is much trickier log equations. I have a worksheet for you guys posted on Google Classroom for you to try, and then to enter your answers into Google Forms, and we'll see how you do. Depending on how you guys do when I look at those answers is going to control what I do tomorrow. So